Hey guys, welcome to the video on linear modeling. So today, this is what algebra is really all about. If you get a word situation, real world application, and you want to write it as a linear model so you can use it to predict future values. Okay, so all of these equations can be represented linearly. So a linear model, as you guys know, we can write it as y equals mx plus b. Okay, if it's linear data, you can write it as y equals mx plus b. Now, what does the slope mean in the context of a word problem? Remember, slope is m. So let's write that down. Slope is m. And that tells you the rate of increase or decrease. It's how much it's increasing or decreasing by. So the rate of increase or decrease. Okay, and then the y-intercept you guys know as the b, that ends up being the starting value. Starting value. Okay, and that makes sense because isn't a y-intercept always 0, comma, a number? So because of that 0, comma, that's the start value. All right, so all we have to do is read through the story and figure out what's the m, what's the b, and then just plug them in. It's really easy. All right, so number one, a truck rental company rents a moving truck for 1 day by charging $29 plus 20 cents per mile. Okay, so the first goal is to write a linear model that relates C in dollars to X in miles. So let's write this down first. X is going to stand for miles, and C is going to stand for dollars. Okay, so the first thing you guys have to figure out is which one's Y and which one's X. And cost depends on miles. So it's going to be C equals mx plus b. Okay, so what's going to be the slope? What is the rate that the amount is increasing or decreasing? And if you read the problem, it's increasing 20 cents per mile. So that means that the 0.20 cents, or 20 cents is the m. Okay, so we're going to write 0.20. And then since it's per mile and mile is x, then we put the x. And then the starting value, the plus b, is the y-intercept. And this car starts by charging a flat fee of $29. So plus 29. Okay, so does that make sense? The b is 29 because that's like the starting value. And then we're adding 20 cents every mile. Okay, so that's our model. All right, now once you guys have the model, we can do awesome things with it. We can plug values in and solve for future values. So B says, find the cost if you drive 110 miles. Well, since miles is X, let's just plug it in. All right, so you guys are going to do cost is equal to 0.20 times 110 plus 29. And then if you have your calculator, we can just solve that. So 0.20 times 110 plus 29, that would be 51. And make sure you have units, $51. That's the cost. And then B says, let's say you had a certain amount of money. How many miles could you drive? So now where does the 300 go? Well, if it's cost, it goes in for C. So this one actually, we put the 300 on the other side, and we need to draw the wall and solve for X. All right, so we would subtract 29, subtract 29. And then 300 minus 29, we have 271 equals 0.20x. And then you guys know, divide by 0.20, divide by 0.20, and you get 1,355 miles can be driven. So that's pretty crazy. Okay, cool. Let's do one more and then we'll call it a day because this one's a little bit harder. Okay, so y equals mx plus b. Now in this problem, let's see. The salary is S. And the x is going to be the number of years. All right, so if it's y equals mx plus b, in this situation, the salary is going to depend on the year. Now, if you guys don't want to put S and you'd rather put Y, it doesn't matter. All right, so Y equals mx plus b. How much is this increasing every year? The problem's up here. Which one of these numbers is the slope? And a nice trick is it's usually the one by the word per, because that tells you it's a rate of change. So the 300 is the slope. Per year is the x. And then what's the original starting value? His starting value was 35,000. All right, let's pick this apart one more time. So his 35,000 was started in 1985, and then it's increasing by 300 each year. All right, so that's our model. Okay, let's try B. So B says, estimate his salary in 1991. Okay, but here's the trick. If the problem started in 1985, how many years have passed? So we're not going to plug in 1991. What's 1991 minus 1985? That's 6 years. So actually, we're going to be plugging in 6 for x because 6 years have passed. All right, so if we plug this in, it's 300 times 6 plus 35,000. And that would be a total salary of $36,800. Okay, so a little tricky with the years. Always make sure you plug in how much time has passed. All right, and then for C, C says, what if they give us the salary? Can you estimate the year? All right, so in this one, the 38,000 goes into S. And your job is to solve for X. Okay, and you guys know how to solve, right? Subtract this over, you get 3,000 equals 300x. And then if you divide both sides by 300, we get x equals 10. Now you're not going to say year 10, right? That doesn't make sense. What year is it going to be? Well, it's 10 years after the starting year. So what's 10 years after 1985? That's 1995. That's the year. All right, guys, that is it for linear modeling. We'll save the next page for class one day. Thanks for watching.